I really, I don't know. I need to spend more time with this stuff, and I just never do until it's the day of. And then I'm like, oh yeah. I'm like, I don't know what I'm doing. I've been doing this for a year, and I don't know what I'm doing. But, you know.
You do.
So, once again, we'll just let it sit here for a second.
It's just hard to test it
It
sometimes.
really is, and like I thought, because I thought I told it to start at 5:45, and I
Hmm.
thought it would do that, but apparently not. So,
And we are alive.
so I'm like, whatever. Okay, let's go home. Where is my video? Okay, yeah, looks like hi, Steve. Good.
Hey.
Hopefully, people are getting the notification. So let's see. Yeah, it might have. I mean, it's got like, it has the right thing, the right um. it had the right graphic, so it got that right. Oh, like hi Meg. So we're here. All right, got a couple people here. Well, let's give it another minute.
Yay.
We'll give it another minute, then we'll start talking.
Sure.
But yeah, we'll talk about the coronal hole that's incoming, and then sub-auroral party that we had, which is fun.
It sure was.
Yeah,
I
yeah,
had I had clouds, and next to a city, even light haze in the sky works as a sort of screen projector.
yeah,
So, with all the haze and all the light that's coming from the ground, it essentially kind of blended the aurora. So normally for that kind of data, I would see it as fairly bright
yeah.
rays, pillars. Um, I just saw a shimmering curtain
Okay.
behind the cloud. It was still aurora. It was
Yeah,
still
right.
cool. So can't complain, but
I
yeah,
know. Like
probably
it was
wasn't in the
in.
best place for it.
Yeah, I
And
guess.
it's really, yeah, it really was a hard prediction because it's really hard to know with coronal holes. You pretty much have to be on the spot and wait for them to arrive and see what solar wind they bring with them because it varies.
Yeah,
Same coronal hole, it's going to be very different next time it comes around.
yeah. This one's
I'm
kind
kind
of.
of I'm kind of giving out the take home.
Yeah, you're already giving all the things away. That's okay.
Okay, bye.
Okay, bye.
We're done.
No, it was good times though. All right, it looks like
Yay.
I think we have a decent amount in here right now, so
Okay.
we can head on out. Okay, head on out. I'm already like I'm out. So
Yay.
anyway, welcome everybody. In case you didn't know, we're doing a little. We like to do forensics. That's kind of what we decided our little niche in this market's going to be is forensics on events that happen because you can learn a lot from them, and then apply that to future stuff. And everybody's trying to get on the forecasting thing,
Hmm.
and it. I'll be honest, it's too much. Like I can't keep up with it. It's just you know too in your face. So we'd like to do forensics and like I said, if you know how to read this stuff, you can kind of do your own forecasting. So that's my little. Are you kicking us out already? No. So anyway, without further ado, I will. Do you want to talk about the coronal hole first?
Sure.
Okay.
Do you want to, yeah, if you want to cover the current kernel hole,
Okay.
so we
Hold
can
on.
get that out of the way, because there's not much of a forecast right now,
Yeah, there
at
isn't. Here,
least.
I'll just bring it over. I'll just bring the screen over right here in front of everybody's face. So, in case you didn't know, and this will be on the slide deck, SDO is out right now. We saw a post that somebody put up about the coronal hole, and it was the image of last week's coronal hole, not this week's
Hmm.
coronal hole. So this is the current one. Because looking at the GOES 19 SUVI
Hmm.
instrument, and you can see it's right here. It's kind of in the same spot as the last one, but
Are
it's
you sharing the screen?
um, I'm not. But
All right.
I dragged it over to the screen that's being broadcast. So I bypassed the screen share. So I know you probably can't see it. Sorry.
Well, I have a different screen up, so I can
Yeah.
see what you're talking
Yeah,
about,
I
but
just
yeah,
dragged it
might
over
as well.
because
Just go ahead and share it.
every time I try to share it, I always share the wrong one. So I'm just I'm just gonna drag it
Well,
over.
I can share it. That's fine.
but
Let
but it's
me pull
up.
up.
So yeah,
All
it's
right.
this little guy right here that I'm circling with the mouse. Um,
Hmm. I'm still not seeing it.
but I think What is it? They put up a G1 watch for this, I believe. That's the thing I've seen.
Indeed, they
Yeah,
did.
and so what? I don't know. I'm guessing here. I'm going to drag it back over here so we can just chit chat. But I'm guessing we'll see this what tomorrow ish, tonight, tomorrow, somewhere in that
Yeah,
range.
potentially sometime tonight.
Yeah.
So, yeah, I'm just gonna quickly share it. I
Okay.
don't know if people
Share it.
actually got a hold of it, but this is what we have. This is SUVI, so that's Ghost 19 images, and this is coronal hole right there. It's negative polarity. Um, Not favorable for the season, but we will talk about it.
Yes, we'll talk about it because
It
last week's wasn't
is
either.
yeah, it's technically very close to equator, but not transequatorial like coronal hole we had before. Chances are we're going to see something from it. As far as what exactly, we have to wait and see. The coronal holes are not exactly predictable. If they're closer to equator, they tend to be more geoeffective, but it can vary. The fast solar wind is not exactly straight the same polarity throughout. It changes, and that's why it's difficult to call. But it's coming.
And that's all
They'll
I
be
gotta say
there.
on that.
Yeah, pretty much, because in terms of solar wind, so going to the real-time solar wind data, oh, that's going too far out. That's 30
That's
days.
wow. Look at
So
all
let's
that.
go to 1 day. Yeah, it's not doing a whole lot right now. Speed is rather slow. Density is very, very, very slowly increasing. I probably wouldn't make anything of it right now. We are in the negative polarity sector, so looks like that was the crossing. It didn't do anything. It just happened. And that's about it. So it's not exactly close to ambient. It's a little bit enhanced. We got BT, so the total strength of the magnetic field is at 7. We got a little bit of a negative BZ, but it's gonna be floppy. So it's mm, right now it's not doing much.
No. So anyway,
All right,
shall we go
that's
on
where we
to
at.
onto our?
Yeah, let's actually talk about what happened. Let's talk about more interesting stuff because space weather right now is not particularly
It's
exciting.
not interesting.
So it was a truly sub-auroral party. Can we gonna talk about what's going on? And this is the SDO outage. It started, as Mary Beth already mentioned, on September 13th. Currently, no ETA on repairs. It's a hardware issue, so I hope they can fix it sometime soon. Um, SDO data is still available, but you have to use alternative approaches to get to that stream. So Suvi is an option, and it's aboard GOES 19, I think. Yeah,
Yeah.
19. It's not quite sharp of an image, and sometimes moon gets in the way, like earlier today. So there are eclipses. Helio Viewer, which is available online and as a separate program, which is JHelio. Both have SDO images streamed directly, so they do have access to the data. If you're looking for it, it's going to be there. And there is another website where you can look at images in real time. Unfortunately, apps that are relying on SDO will continue to show this picture. So check the date. Always, it's going to be here. And if you're not sure, then go to live data on basically SWIPSy website. That's probably your best source right now, unless you really want to play around with sort of other sources.
Yeah.
Very exciting news. That is probably the best news this week. But we do anticipate SWIFT L1 launch and IMAP launch, which is NOAA and NASA missions, respectively, to L1. They're going to be feeding us real-time data with a very short cadence. So that's going to keep us updated on what's going on in solar wind. There will be a coronagraph. Hopefully, it's going to be looking a little better compared to what we have with GOES 19, but that remains to be seen. And launch is scheduled for tentatively for Tuesday. There is alternative dates in case the weather doesn't cooperate. And we hope the space weather cooperates because you don't really want to launch it into a major CME and a shower of energetic particles. But
Yeah, that would be
watch it
bad.
live. It's going to be early in the morning. I intend to watch it. It's a little nerve-wracking because three missions are going aboard one
One rocket.
Falcon X. Yeah, it's
Yeah.
Falcon 9, I think, that they're using to launch it. They're going to be deployed at slightly different times, so it's a staggered deployment. IMAP is going off first, followed by Swift L1, and then another probe is heading out. But this is really exciting. So wish them luck.
Yes.
Pray to whatever gods you believe in, be it Enlil or another deity. But we're hoping we're going to have some replacement for
Yeah.
Ace and Discover.
I know it was being
Um,
discussed elsewhere about because, like we were saying, it's like it's kind of risky putting all of this on one rocket, but Falcon Nine's success rate is pretty good.
yep,
So,
precisely.
so cross
And
fingers.
yeah, cross the fingers, watch the launch. Time to operations is expected about April of next year. We should be getting the data. They're also planning overlap between ACE data and Swift L1, which will be, I think, Sol 1 when it is finally operational. And we will have a chance to compare what they look like when it comes to data. So we'll have several data streams to choose from, and it is, yeah, as I said, it's super exciting. So
Yeah, it's been
go Swift L1.
it's been a long time coming.
So let's go to a recent event. Mary Beth, you want to cover this
Yes,
coronal hole that caused us some interesting trouble?
it was definitely interesting. So this was the one we were waiting. Well, yeah, actually, that was the other interesting thing was it seemed like it arrived on a little bit later than anticipated, because some of the forecasting had it like the 13th, like as
Mm-hmm.
early as the 13th. So that was kind of interesting. It ended up showing up late afternoon, well, Eastern time, and Sunday. But it was negative polarity, transequatorial. So, I mean, we just got done with this big stream about the Russell McPherson effect. So we're like, oh, negative polarity. It's this is the wrong type of polarity for this time of year. And then we got a G3 out of it. So it's like,
Yeah. I mean, forecasted storming was G1, G2, and
yeah,
then that coronal hole showed up and said, well, hold my beer.
yeah. So
Um,
it was interesting, but it had a pretty strong CIR with it, and that can drive a lot of this activity, and that's kind of what we saw. So, I guess we can go to the next because, as you said, the
mhm.
forecasting was G1, G2 at most, but we got G3 out of it, and in this solar wind plot, you can see, hopefully, where that compressed magnetic field that minus 10 to almost, I think it was 17
Mhm.
at the highest
Yeah.
BZ. So that was your driver, right there. Um, well,
And it was prolonged. So
mhm.
it really takes prolonged negative BZ to do some mm, fairly nasty stuff at times. But it was a very rapid transition to a very sharp drop, which definitely helped to get things moving very fast.
Yes, to say the least. And you can see, I mean, in the rest of this, you can see typical coronal hole, density decrease, speed increase. And these coronal holes have been pretty potent. I mean, with over 700 kilometers a second speeds. So
Oh yeah.
they've been pretty good. But as you see, the after the initial CIR, it just kind of, the BZs were pretty much near
Yeah.
zero. Yeah, with like little.
Once it sort of reached the cruising altitude,
Hmm.
cruising speed, it just dropped off. So this is that sort of reverse shock almost.
Yeah,
It still had some negative BZ, so there was some storming, more like substorming later, but
yeah.
this was the period when we saw most active stuff. And we lucked out in North America. It was our time to party.
It was. It was timed really good. Basically, as soon as it got dark. But yeah,
So
here's
I can
where.
probably cover this.
Yeah, it's like where did
The
G3 come
G3,
from?
yeah, the G3 really came from that compressed magnetic field that contained a prolonged interval of negative BZ, so very favorably for us oriented, and it definitely connected with the magnetosphere and caused some damage to it. But it was unexpected because again, it's unfavorable polarity, so everybody pretty much dismissed it. First, it didn't show up as expected. Well, it did on its own time. And then it caused this not massive, but fairly impressive storm for the coronal hole of any polarity.
Yeah.
It's somewhat unusual to see this level of storming out of the coronal hole. It's not completely impossible. So it's not entirely clear why exactly that happened, and there could be multiple causes, and there could be more than one cause playing into this level of storming at the same time, or this type of solar wind pattern at the same time. But size and shape of the coronal hole do matter. Um, if it's spread out, chances are it's going to be stronger solar wind. It's going to be more of a sharp onset of the fast solar wind when the border is that clean. Could it be a stealth CME? Well, we didn't see anything that would suggest that there was a CME admix because everything was moving fairly erratically except for BZ. So, is it possible that this island of in, or those tiny islands of opposite polarity, because all that blue is negative polarity.
Mm-hmm.
Well, actually, it's positive polarity. Blue is positive, red is negative. So there is some red polarity, but there are speckles of opposite polarity, and it's when it's an island or an area of opposite polarity to the coronal hole that contains its called parasitic polarity. So could it be that BZ was coming from those areas? Possible. Mini CME, we have seen those with past fast solar winds. Again, no clear signature of the CME, but sort of baby CME that could have been launched and just mangled up in transit. Again, solar wind evolution on the way to us. But I am favoring just sheer dumb luck. It happened. Could it be predicted? There are multiple theories again. Could we operationalize? Meaning, if we see coronal hole of the same size within islands or areas of opposite polarity, even if it's unfavorable polarity for the season, could we expect the same level of storming next time? I don't know. I don't think anybody could predict whether or not this would happen next time. Coronal holes are fairly complex solar wind factories. It's not just all is streaming on open field lines. There are interconnections. They're very active, and I think we may need to cover it separately because there is a lot of stuff happening inside those coronal holes that drive solar wind. But how it's going to play out, I don't think we can tell. So, long story short, it happened. Why exactly and what factors played into it, it's going to be really difficult to prove. It's going to be even more difficult to predict based on what coronal hole looks like when it passes the central meridian and sitting at the equator, what it's going to translate for in terms of aurora and storming. We have to wait and see.
Yeah. So a
The
couple.
most interesting stuff about this.
Well, like a couple things came up. It's like, so Janelle was like, so can we expect to see this again next month? And I'm like, nope.
Maybe
Maybe.
it's hard to know. We don't know. We have to
because
wait for
because
next
the
month
month
because
prior it didn't do it,
no. And
and then
I
it did
do
here,
have,
and that yeah,
yeah, we do have a slide to look at the prior rotation, but we could expect that it's going to do something
yeah. It's
next
just
time it passes because it has delivered fairly strong solar wind. So it had areas of fairly impressive magnetic field compression. And if that comes with the negative BZ, yeah, we could get decent storming out of it. Is it going to be exactly the same? Probably not, because coronal holes do change their size, they change their shape. Sometimes they do shift their location a little bit. They're sort of locked as far as where they're coming. They're fixed to the longitude, so that's why they rotate every 27 days. But we have to wait and see. But
and
if you're planning to see Aurora in 27 days from last Sunday, you might want to take a few days on either side And if you want to go somewhere north, if you have time and patience, most importantly, and high tolerance for disappointment because it may not be quite as spectacular, then by all means plan your hunt, plan your chase around that time. So
Yeah.
hope that makes sense.
So
So
and then the other thing is, do you have that information on the parasitic polarity islands? I know you have a paper somewhere probably.
there
Like,
are some papers, but it hasn't really, the role of that parasitic polarity has really not been explored as far as how it translates into geomagnetic storming. So I think it's a pretty neat hypothesis, but I don't think we know for sure. There's not a whole lot written about it, and I found just a few papers that are describing it. They do participate in those interconnections. So inside coronal holes, they're sort of switching back and forth between open and closed fields. On the quiet sun, you see those coronal loops. Those fields are closed. So particles are just circulating there and they're not going anywhere anytime soon. That's why we get very slow solar wind, very few particles escape from those areas of sun. But then we get coronal holes, and it's sort of mini CMEs, ejections that are going in all directions, oftentimes with very strong deflections, which is why when we see the coronal hole that's sitting above the equator, still close to us, think about those tiny, tiny jets that are getting strongly deflected and still reaching us. That's why.
yeah.
So they're tiny, tiny jets. Well, relative to the sun, they're tiny. They're really, really not that small.
Right.
But that's what's giving us that fast solar wind. So it's not literally a hole that's open to the interior of the sun. There are loops there. It's just they're fluctuating. They're sort of switching between this is closed, this is open, and streaming into space. Hope that makes it
Yes.
simple.
As simple as you can be.
Yeah. I mean, they're complex structures and they're when we look at them in different images, they look like literally like holes, but that's because it's cooler plasma because it's escaping. So it's not heating to the same degree on the sun. But there is no hole there. It's
Right.
still corona. It's just fluctuating between two different states of sort of magnetic field, open to close, close to open.
And that's why you can get those little islands because it's not a hole.
Yeah, exactly. There will be there. And they will participate in that in those exchange interconnections.
Yes. Now we can talk about EPAM, our other favorite thing.
Yeah. So, I think we've covered EPAM and we've covered the fact that CIR and SIR, so SIR stream interaction region, when we haven't seen that coronal hole before, CIR is co-rotating, meaning it's been around the sun at least once. And we've seen it before, but they can accelerate particles because they can drive shocks. And that's exactly what we saw. There's a little bit of, it almost looks like but we don't see electrons arriving with it. That's mostly protons. And the magnitude of that peak is a lot smaller compared to CMEs. This is logarithmic scale, so sometimes we forget that, oh yeah, there's like huge peak there. It's not that big.
Right.
And the levels of particles, they were elevated for quite some time. So that was likely just coronal hole driving it. And we have seen it on previous passes with the same coronal hole. So strong solar wind can accelerate particles because it starts to look like a shock.
Yeah.
So
Because I remember this being tossed around in Twitter about
yeah,
incoming CME, but it's not a CME. It's
yeah. And the problem with CIR and using it for and sort of EPAM rise related to CIR. Unfortunately, that peak with the CME, that peak we see it when shock arrives. That peak with CIR arrives way after the magnetic compression is here. So this is the same plot for solar winds. So speed is elevated here, And if you're waiting for it to peak thinking it's going to be more fun, well, you just lost most of that negative BZ prior to arrival of the peak of the shock,
Yep.
the accelerated particles. So do not wait for it. Do not chase EPAM because coronal holes can fool you on that one.
Yes, they can.
Mm-hmm. So this is the difference between those. It's the same coronal hole. So two things that happened between those two rotations. It's a little further south in the hemisphere, and it had those big. Actually, those were parasitic polarities. Those islands were of opposite polarity to the coronal hole on the previous rotation. It lost them. It got wider.
Mm-hmm.
It got more open, and this was the level of compression before. So it actually is fairly similar.
Yeah.
So this coronal hole can definitely drive things. It can compress the magnetic field with a fast solar wind. But look at the level of substorming. The scale is the same between those two plots, so it's easier to compare. There's definitely some activity. It's not a complete waste, and it's coming during that strong magnetic compression, and some of it is coming from just negative BZ. But look at this one.
Yeah, look at the difference.
Look what happened here. So it dropped like a rock when that negative BZ arrived. Didn't take that much to charge it. And as long as BZ was negative, it was producing some interesting substorms. Again, was BZ stable? Did we go sawtooth where you see substorm every 3 hours? No. It was still fairly erratic and basically end up with very complex picture. But eventually it moved into recovery, which is where fun stuff started to happen. So
Yeah.
it almost looked like a reverse shock where you just lose the strength of magnetic field very rapidly. And the speed is still going up. I don't have plot for density, but I don't think it was quite clean cut reverse shock.
Right.
It was just basically drop. The magnetic field is no longer compressed. We're in a pristine fast solar wind. We're kind of done with the biggest part of the storm, but it got us to G3. So thank you, Colonel Hole. Come back again.
Yeah. Come back.
We love to see you. So yeah, talk about geomagnetic fun. So a lot of it happened for the North American evening to into the night. So again, you can see how BZ is affecting the storming. You can see where things start to happen, where Aurora cooks, so to speak.
I always like these plots. These are just fun because they do a great picture of explaining what happened.
Exactly, and this is propagated solar wind, which means what you see here is what Earth was seeing at the same time.
Mm-hmm.
So negative BZ arrived a little bit later. We're starting to see fairly strong activity because it was a very, very rapid drop into negative BZ. So it charged, and it charged strong, and it charged fast. But let's talk about what really happens and how that energy is transferred. So energy comes in on the day side, and it builds up on the night side. So we think about substorm as a way to sort of disperse that energy and sort of redistribute it from the tail, from the night side into greater magnetosphere and ionosphere and actually do the aurora. So that drop is very sharp, and it followed by a recovery. By the way, I had to search really hard to find an isolated substorm because it's easier to read and it's sort of easier to see what happens.
Right.
So when you look at the area of how much energy is actually going into this, substorm does not dissipate a whole lot of energy. The area up to that peak, so to speak, this is a peak of expansion, it's pretty small. But what follows that is long recovery. And in recovery, this is where the majority of energy is being dissipated. And that may explain why we see certain things. So think about it as that substorm onset is sort of ignition spark, and a recovery phase is when you have the live circuit that keeps on going. Aurora may look very different during that time. So substorm, particularly onset and early expansion, you get beautiful rays, you got those pillars, you get curtains that are moving in all directions. And then in recovery, it starts to be patchy. It may be pulsating. You start to see sub-auroral features. Well, you start to see sub-auroral features because there is a lot of energy still going on and being dissipated. And aurora and substorm were not enough to dissipate that energy. So it's going to go into fun things like pulsating aurora, and
Yep.
it's going to go into sub-auroral features. So remember, just because the substorm is the expansion part of it is over, doesn't mean that the fun is over.
It just got different kind of fun.
Yeah. So we saw some fun stuff on both diffuse aurora, which is why it's important to look at all kinds of auroras. They're all beautiful, they're all interesting, but this is a unique feature of diffuse aurora. It may not look much when it's far on the horizon, but if you're fairly close to it and kind of looking at with a wide angle, you start to see those undulations.
Mm-hmm.
They're kind of like scalloped edge, and sometimes they look longer, sometimes there is a little bit of a curl to them. It's a pre-onset feature. You can only see it on the evening side. You don't see it past midnight. You start to see different features on the after midnight. But this is evening, and because majority of that strong activity happened on North American evening,
Yeah.
that's why we got to see it. So what else do we see here? This is proton aurora. So this is main aurora. It's diffuse, it's scalloped, and it happens prior to onset. And proton aurora, which will be next,
Mm-hmm.
it's there too for the ride. Because again, it was pretty strong driving, so you have both electrons and protons that are literally falling out of the sky. So thank you, Patrick, for that photo. It's amazing.
Yeah.
So, Mary Beth, this is yours.
Yes.
You want to talk about this?
I mean, it's got all the different things in it. That's what struck me about it. You know, it's got the proton aurora, pulsating aurora, and then the other thing that's kind of neat is the colors. It had blue and purple in it too, which is something I don't see very often, and
Mm-hmm.
so that was pretty cool. I still haven't really talked to anybody to see what exactly that was. Um, I mean, but it was neat that it was there. It just more along the theme here that this was a pretty energetic event.
Yeah.
So
Yep.
there's a lot of a lot of energy being shed in various different forms.
Mm-hmm. And this is pretty close to expansion, although
Mm,
I would say that's probably past the peak of expansion because you
yeah.
start to see kind of aurora breaking down. But proton aurora is still there.
Mm-hmm.
So you can't really see that much of a color difference because it starts to all blend in. And when you blend the color, you start to see more of the kind of greenish yellow. So that's this is more typical for the main aurora. So there is a little bit of a yellow because there is some nitrogen that's glowing. So it starts to blend in with the green, but you see the red. So that's oxygen. You see the green, that's again oxygen. That blue is a bit of a mystery. I mean,
Yeah.
it was still fairly close to sunset, so it's possible that was just the sunlit aurora. However, it's a part of main aurora as a single ray rather than tips of it. So I would say if you have a photo of it that's showing how tall it is, it could be a very different feature. I didn't include it, but there is a giant blue ray aurora that can happen too.
Yeah.
Not a lot is known about it, and they're actively studied. So if anybody caught those giant blue rays, then it would be good to know about it. Definitely submit your observations to Aurora Saris. It would be really cool. But for the isolated proton aurora, they're not pancakes. They're not pancake aurora. Sometimes I've seen this term. It's like, no, please do not call it pancake. It's just isolated proton aurora. They're more typical. The color is kind of greenish blue, almost teal,
Yeah, that's to me it looks
because
teal.
yeah, and like this one is
Yeah.
looking slightly kind of teal. I can probably go to the previous one, and oh, I don't want to annotate. Hmm.
Because that's the one thing I've noticed right away with the proton aurora is that it's more of a teal color. than the regular stuff. So it's kind of neat.
Yeah. So this is,
Mm-hmm.
you can see the difference.
Yeah.
This is slightly, yeah, this is kind of teal because it's a different type of um, particle interaction. You get a little bit of a hydrogen glow here. And that's how protons go. They chart when they travel, when they precipitate, when they're accelerated and bumping into lower layers of atmosphere, they can actually gain an electron and they become hydrogen. And those hydrogen, when it loses electron, again, it becomes a proton. So that interchange can go for a while, and that contributes to a different feature. I think I have it next.
Yeah, I think so too.
I have it ragda. So we get a little bit of electron precipitation, again, from that proton high up in the atmosphere, gaining electron, then losing it, and that electron's going to bump into oxygen and it's going to glow the same red that you would get out of main aurora, out of pillars higher up. Lower, it's going to blend with more hydrogen emission. Hydrogen is more bluish, and you can get oxygen that glows green. So you blend the two, you kind of get a blend of color. And Ragda is, again, typically it's a red arc with diffuse green aurora. It's literally an acronym.
Yeah.
It used to go by the name of red-green arc. It's a type of proton aurora. There is no mystery. There is no special other particle that does this. This is just proton aurora with extra energy and a little bit more electrons that it picked up on the ride. Kind of blue-green, diffuse patches. A red arc may be rayed sometimes, and it is separate from SAR arc. So this is kind of a little bit of a SAR arc. What's cool about this photo is, so thank you, Patrick, for this, but you see the main aurora reflecting in the windows.
Yeah, so that tells you the
It's fairly
direction.
active.
Yeah.
And both proton aurora and ragda, again, they're the same thing, just appear differently. They are equatorward of the main aurora for the evening sector. So for before midnight, they're going to be on equatorward side. So it's going to be south of the main aurora for northern hemisphere and north of the main aurora for the southern hemisphere. And usually it is seen in recovery. It gets enhanced during the substorm onset, and you definitely have a lot of those things being pumped in. But again, recovery is the time when a lot of energy is being transferred into essentially aurora and heating, and you get all those fabulous features. They start to separate and be really evident. But yeah.
Yeah. That what does
And
that bring us to now? Our
well, that
favorite,
brings us to another good point because those patches, you can see they're not uniform.
yeah.
This is kind of thicker, this is thicker. So they can come and go, and that's typical for proton aurora too. It's not exactly like pulsating aurora. Pulsating aurora pulsates very, very fast, very quickly, but it's more slower type of pulsation. It's sort of it's glowing, then it subsides, then it becomes kind of starts glow again. It may be a patch that's in a different area, but a red arc tends to kind of stay and it sticks around a little longer than those pulsating patches of proton aurora. Kind of cool.
Yeah, it's been a while since I've seen it, so it was neat.
Yeah, and you can get overlap with a SAR arc depending on your angle of observation. So and then it becomes really challenging because you can see those both of those arcs in the sky at the same time. So if you happen to be under proton aurora and there is a SAR arc, you can start to see the overlap. There is enough energy usually to drive both, so it's not unusual that you're going to see both features at the same time. And then positive ID, as far as what type of feature it is, it's next to impossible.
You got to find something that's further south.
Yeah.
Separate it.
And Michelle, huge thanks for this photo because this is Steve, and this part is Steve, so it's almost white.
Yeah, almost.
There's a little bit of a pink to it, and that's pretty typical, but usually it starts as a SAR arc. So SAR arc is a sign that There is a lot of energy that's been transferred, so it's starting to heat certain particles in the inner magnetosphere, so higher, really high, very high atmosphere. But and it's a flow of particles, and that flow generates the heat. But if it becomes very, very fast, which is typical when a lot of energy is being transferred, you can see that transformation from SAR arc into Steve. It's Aurora-like arc. It can come with picket fence or fingers that are green, and the green is also very different shade of Aurora compared to main Aurora. It's always a crater word of the main Aurora, and typically happens again in recovery phase when a lot of energy is being dumped. And what's interesting about this in particular is the closer to midnight you are when a big storm enters recovery phase, the greater your chances are of seeing Steve and SAR arc. SAR arc you can see pretty much at any time. If it's strong enough, if storm is strong enough, there you can see it at different times. But Steve is more typical, kind of closer to midnight.
So basically,
Always in recovery.
yeah, so basically, this was just a well-timed event for us.
Yeah, yeah, absolutely.
The takeaway here.
Yep.
After all that disappointment, we finally got one.
I know.
Timed right.
So, Michelle, thank you for this photo, but it's sort of our wrap for this one. Coronal holes are definitely worth watching, particularly if they're big. So large area, transequatorial, because they can deliver a punch that will be beyond your expectations. Or it could be your greatest disappointment.
Right.
That can happen too.
It can go either way.
Yeah. Aurora may be interesting in all phases of the substorm cycle. There is definitely a focus that I have seen that people want to capture those watermelon shots, so pink with green aurora, but you can see dunes, you can see that giant undulations, and that happens before substorm. They're really cool features. They're diffuse aurora, so it doesn't really appear as much from far away, but closer to it, it could be a lot of fun. And you can see sub-auroral features too. You can see proton auroras, you can see SAR arcs, you can see Steve, but the thing is, you have to chase the live data, not the forecast.
Yes.
And always, always, always look at the entire sky, because the most interesting feature could be behind you. Like, this is main aurora in expansion. We can see that it's not broken up yet. You can see beautiful pink, red rays. But this is ragdown. So there is a little bit of a pink arc making it through, and big proton aurora blobs. They start to look a little different when it's on the horizon, because again, it's the angle of observation. You just pick up just slightly different color when it sort of stacks up. But this is very close to overhead, so that's pretty cool.
Yeah. I know, to your point there, because I was, I only had a couple cameras out, so I didn't have anything pointing south, so I didn't get the Steve. So, to your point, yeah, you gotta look all around.
All right. Well, I'm gonna stop sharing.
Yeah. So that was our little tour to Sub-Auroral fun. It was cool to see.
Yeah.
There's hi Justin. He made it in.
Yay!
I know he took a chance on a location, ended up getting a bunch of clouds, but he got some cool stuff. I saw him post some pictures. It wasn't totally cloudy, just partially. It was fine.
Yeah. Yeah, it's really hard to know whether or not it's all Russell McLaren effect, because again, the BZ that we see is the BZ that we get. Mm-hmm. It's a complex conversion from the satellite to translated from solar coordinates to magnetospheric coordinates. It already takes into account how Earth is positioned relative to the sun in terms of the tilt. So that conversion is done for us.
Yeah.
Um, again, it could be favored because of it's more likely um, to happen during equinoxes, but to what degree it actually had effect, it's hard to know.
Right. Yeah. I know one of the questions that I had on Facebook was like, because I guess we'll talk about this too, because the equinox. Somebody's like, well, is it going to be good for the equinox? I'm like, the equinox is kind of a time frame, you
Yeah.
know.
And again, it
Yeah.
was a wrong polarity. So
Right.
trying to say that this is all Russell McLaren for wrong polarity coronal hole, that's a stretch.
Yeah.
Don't know.
And then as far as like things being good for the equinox, I mean, we have a coronal hole incoming, so maybe. But yeah, but
Yeah.
I don't know. It's just it. But again, it's like a time frame too. So it's not just you have to be, hey, it's if it's not good on this date, it's not going to be good anywhere around it, and that's just not the case. Like this effect kind of lasts a couple months really. It's more,
Yeah.
like we had last week. Like there's a certain date where it's like the strongest effect because because we're always moving, but it's a couple month long thing, really. That's what I'm trying to say.
Yeah. That's very true. But we do have a negative polarity coronal hole that's incoming. Again, it's a wrong polarity for the season. Doesn't mean nothing's going to happen. I mean, it's still a coronal hole that's fairly sizable, so something will happen.
Yeah.
There is a positive polarity coronal hole that is unfortunately locked in with full moon
Hmm.
that will come back eventually with a full moon. And could it deliver fairly decent storming? It's possible. Is it polarity related? It's really hard to know. So do not dismiss wrong polarity coronal hole, particularly when it's sitting and it's transequatorial. It may not arrive as predicted because, again, we can't say for sure when they're going to show up. It's sort of a window of arrival, so we can say approximately when it's going to come. And again, this was very unexpected, and I don't think we're going to find out for sure why. First of all, second, just because we know what it translates into with this particular pass of coronal hole and how it became to be, it doesn't mean that the next pass will be the same. And also, it doesn't mean that we know all the factors for sure to just be able to look at the coronal hole and say, oh, yeah, this one's going to deliver G3. There is no way to do it.
Right. Yeah. So there's our takeaways for the day.
Yep. There is a factor of randomness into this
Yeah.
into this too.
I always feel like we're the bad news people because it's like because nothing. We're like, well, can you forecast it? Like, well, kind of, but not really.
No, but watch it, see what it
Yeah.
delivers. If you want to be in a more favorable location and wait and chase substorms,
Yeah.
and
And that's what you can
that's
do.
okay with you, this is what you do.
Hmm.
This is what you do as a chaser. And when it turns out to be like a G3 storm that wasn't forecasted, hey, that's great for Aurora.
Yep.
Not so great for industry, unfortunately. I kind of feel for SWIPC and Met Office because that was not anticipated. And at G3 level, they typically like to advise the industry that something stronger will be coming. So again, that just tells you that our forecasting is not perfect.
Nope. And it probably won't be for a long time.
Yeah.
It's just and a lot of that's just because we don't have the available data sources to do it. So we're
Yep.
still.
And yeah, it's a complex process. It's amazing that we are able to do at least something.
Yeah. Yeah. I often think of that. It's like as frustrating as this is, it's amazing we got what we have
Mhm.
with very
Yep.
minimal sources. So got to keep that in
Absolutely.
mind.
Yep. Absolutely. So, Ray has a question about proton aurora,
Uh-huh.
diffuse plus different hue. Yes.
Yeah.
Yeah.
Yeah, that's what makes it kind of cool. I think is like because the teal color is what always gets me
Hmm.
because it's like it's so different
Yeah.
than the other color.
And proton precipitation is always there. It's
Mhm.
always part of aurora. Most of the time, we just can't catch it.
Yeah.
There's just not enough of it. This was a very energetic event, so it pumped a lot of energy into proton aurora, including, and that's why we were able to see it. And I think people reported it as naked eye visible,
Oh yeah,
those patches.
it was very
And
easy to see.
yeah, and camera definitely saw it. So yeah.
Yeah, so it was definitely pretty very easy to see, so that was cool.
Hmm.
All
Yeah.
right, I think that covers it. So, if anybody else has any questions, speak now.
I'll post it in comments
Yeah,
later.
or post it in comments, and maybe we'll talk about it later. But that's all we got for today, I think. And no, it was good. It was fun. Like I said a couple times on the stream, it's like after so many times of being on the wrong time, it was nice to finally get something, you know, that was worthwhile. So in that respect, it was cool. So we'll
Yep.
see what next month brings, if anything. I know it's I mean, no, it still should be good. I know we're starting to get into more of the cloudier part of the year, but October is usually pretty good too. So
Hmm.
anyway, we shall see. And on that note, I will let you guys be for the evening. So thanks for tuning in as always, and we'll come up with something for next week. I'm sure we will. So
Yep.
if not, if you have a suggestion, let us know. So for now, I will let you guys be. So have a great have a great evening, day, wherever you may be watching from, and we'll see you next